Okay, so, like I said, how does it get trickier? So we're going to do more with inverse trig. Okay, so all that we're going to do is add a couple of layers to what we were doing yesterday. All the same rules still apply. We're still going to evaluate everything the same. It's just what if you see more like a composition, okay? Like maybe a problem nested inside of another problem, okay? So something, for instance, maybe something like this. The arc tangent of the sine of pi over 2, something like that, okay? So it's a problem within a problem. Please understand this is not a multiplication relationship. This entire thing is taking the place of the angle that's, or not the angle, but the value that's supposed to be behind arc tangent, okay? And so when you see something like that, guys, you know what it reminds me of? It reminds me of that f of g of x, or g of f of x. And remember when we were doing those, no matter how ugly they got, you could just start at the back and then go to the next level and then go to the next level. This is the same. You want to start on the innermost set of parentheses and just take it from there. So don't wig out on the arc tangent, okay? So sine of pi over 2, we should know that, right? What is that value? 1, right? Because that's just saying what's the y value at the top of the circle, right? So this whole thing just turned into arc tangent of 1. So now it's just like what we were learning yesterday. So now we see an arc tangent in front of that. So the angle that has a tangent of 1 is going to be what? Pi over 4. And that's how you reason through those. So not terrible, hopefully, right? It's just kind of adding a little layer to what we were already doing. And I'm not going to try to trick you like I will try to make all of them possible, but I will say sometimes you could run into a trick question. In other words, like sometimes you could have a not possible depending on what they lay out, or maybe something that needs a calculator, and we'll kind of talk about those in just a second. But first, let's do, I'll have you guys do one. How about the cosine of the sine inverse of negative 1/2? Okay, so I've switched the order on which one's the inverse, but it's the same idea. Those of you that were absent yesterday, what you're going to want to write down is when you see inverse or arc, your brain always wants an angle. So you might want to write down a sentence like, this is asking you what angle has a y value of negative 1/2. And then we are restricted to specific quadrants for sine, so we have to be kind of careful. Inverse sine, we are restricted to this part of the circle. So who's got me on where this is going to occur on the circle? Somebody's got me. Sine, the y value of negative 1/2, definitely quadrant 4. So is it the one with the pi over 6 or the pi over 3? Good. And so it goes with pi over 6, but it's down in quadrant 4, so we're going to call that negative pi over 6 instead of 11 pi over 6. Okay? So this just turned into the cosine of negative pi over 6, which is theoretically, right, cosine of 11 pi over 6. They're the same place. So what would that x value be? Very good. Root 3 over 2. And that's how we're working through that. Who got that one right? 3 people? What the what? Okay, let's do another one then. What questions do you have? Yeah?
Why would you not use 11 pi over 6?
So like the setup of why this is restricted was basically our all day yesterday and how it all comes from the graphs. I do have a video of how we established this graph and how we talked through it. But basically it's going to come down to the graph of that dictates how you answer the question. And you are only allowed to answer numbers 0 to pi over 2 or 0 to negative pi over 2. So you're thinking about going clockwise around the circle. So we're answering like that. Okay, and the same thing, remember, which one also matches this? This is arc sine or what? Arc tangent. What was the arc cosine's quadrants? Very good, top half of the circle. So when you switch over to arc cosine, you get to use the top half. Okay, so what else could we maybe do that we haven't done yet? No one's asked yet about, maybe like a good old-fashioned arc secant. How about that? Okay. And I didn't even layer this one. It's just, we haven't talked about the reciprocal functions yet. And we didn't do the graphs for the reciprocal functions, but we don't need them. Okay, we don't need their graphs. What we need to know how to do is how to legally change this into something that we can handle. Now, in math, there's a lot of things I wish you guys learned, like in Algebra 1, that would come into play now. But for some reason, it's like they don't have faith in you. But if they had shown you this stuff early, this would be second nature. It's an expression, and as long as you change it fairly, you can change things and manipulate them to your advantage. And what I'm talking about here is the fact that, number one, this is a poop problem. I don't know this. We're erasing that. I was thinking of something else. I think some of you know what I was thinking of when I wrote that. I guess I should have done something like this. Okay, that's a secant value. So if we're doing it without a calculator, this is what we would want to do. Okay, so when we see this, I don't know my secants. Now, we did secants on that big chart of 1,000 values a couple weeks ago, but I'm not going to ask you to get that out and look it up, okay? Instead, we're going to change it so we can do it easily. And the way we're going to do that is we're going to reciprocate this. But to do it fairly, we need to reciprocate everything. So in other words, if I can do the reciprocal of this, then I can do the reciprocal of this, and that will be synonymous. That'll be like the same place. So what is the reciprocal of secant or arc secant? Good. Secant goes with cosine. So we're going to go and turn this into an arc cosine. So the relationship there is they are reciprocal. So I'm just going to change it right off the bat to something my brain can handle. I need to reciprocate this. So what's that going to be? Good job. -1/2. Remember, that's over a little invisible 1 right now. So we're just doing a reciprocal. Okay, and now it's easy peasy. Arc cosine, you're restricted to the top half of the circle. We're thinking of an x value that's -1/2. That's going to happen somewhere over here. Where's that going to be? Where is that? Is it at the over 6 or the over 3 in quadrant 2? Y'all don't look at Eli. Y'all know this too. Huh? There we go. It's the over 3 one. So that is actually 2 pi over 3 in quadrant 2. So that's going to be our answer. Is that all right? Not bad. Kind of a little trick to help you out so it's not as hard. If you didn't do this, you would have to go through the formula for secant, which is 1 over x, and you'd be plugging in numbers to see what worked. And I don't want to do that. So it's easier to just flip them both and go from there. Okay? All right. How about we do the tangent of the arc cosecant of 2√3 over 3. Woo! That one looks hard. Let's do it. Okay. All right. We're going to start on the inside, and I'm going to need y'all's help thinking. So if I just ignore the tangent, arc cosecant reciprocals with what? That is so not poor, good grammar, but I don't care. Like I told you, I didn't pass the other subjects, just math. So what goes with arc cosecant? Sine, right? So arc sine. So I'm going to change this right off the bat to arc sine. And if I change that, I have to change the other. Okay? Now, when I flip the other one, it turns into this, which you're probably like, that's not on the unit circle. But wait, it is, because what could I do with this to clean it up? Yeah, y'all go and rationalize that real quick and see what it turns into. Some of you probably already know, but I want you to see that it works. Isn't that fun? It's kind of like a do it once to see that it works, and then maybe from here on out you'll remember that value when it shows up, and you'll be like, oh, that's going to go with root 3 over 2. And here's the deal. If these are from the unit circle, you don't have a lot of choices. You know what I mean? Like, it's going to be 1/2 root 3 over 2, root 2 over 2. It's going to be one of those. So this turns into root 3 over 2. And if y'all have a question about that, and I wrote it out over there, but let me know if something doesn't make sense. I just kind of skipped a few things and just wrote it out. Root 3 over 2. Okay, now we can go. So, on the inside, I needed an angle that has a y of root 3 over 2, and that's going to be pi over 3. Awesome. Then on the outside, I'm applying the tangent to the pi over 3. So we wrote those down, or you can figure them out. Which one is that? Pi over 6, pi over 4, pi over 3. Oh, wait, I'm stupid. I'm trying to go backwards. Sorry. What are the values that go with it? What did we write? Root 3. 1, root 3 over 3. Those are the values that you have a choice on. But if you remember that order, and you know where pi over 3 is, it does become easier to just crank it out and give that value instead of actually having to do the math. Now, let's say you don't want to do this. You're like, I got too much in my brain, not going to focus on that. Just so we're clear, you would have to go through the y over x of pi over 3, and you would have to show yourself that math, okay, if you're not going to commit those to memory. So that's the why it works, and those are just the straight up values if you want to memorize. All right, we feeling okay? All right. There's one more thing I want to do that I haven't taught in a couple years, actually. So this could be fun. I was helping somebody in college trig at UNT, and they were doing the same unit. And on their inverse trig, it was unit circle stuff, and then it was stuff that was like in a calculator. Do y'all feel confident you could just type them in a calculator if you had to? Like, we know to hit, like for inverse, you hit second, whatever. You would check your mode for radians or degrees depending on what's given. So that shouldn't be too bad, I hope. Okay, but I mean, I can give y'all something to calculate if you want. But then they had a whole section that was like not unit circle, but it said do not do with a calculator. And I was like, okay. So this is what they look like. And I want us to try it and just brainstorm how we could do it. What was it? It was something like, okay. It was like arc sine. Something like that. Okay. All right. So, like I said, no calculator and not unit circle. Like that definitely, you're like, what? That value's not something we had to memorize. Okay. So if this happens to you, it's actually really wicked similar to some stuff we had on the last test. It's just written a different way. So remember the ones in the last unit where I would say like, hey, y'all, if the if the cosine is 3 over 5, find the tangent or something like that. It's kind of the same exact thing. And if you were given something weird and the sides were not unit circle, how did we have to do those problems? We made a triangle. And that's exactly what we're going to do here. That's what we're going to do. This is saying what angle has a sine of 5 over 3. Well, the sine is the y over r. Or you could think of it as the opposite over hypotenuse. Either one of those is fine, however you want to think about it, okay? So I would think about it as, I'm a big fan of y over r, but like I said, if you want to do opposite over hypotenuse, either of those is fine. And I would draw a triangle. Now, I'm going to draw my triangle in the first quadrant, okay? Why did I choose the first quadrant? What do you think? Good. This is totally positive. Yay. If this had been negative, just so we're clear, there's only one other place I could have drawn this triangle. Who knows the answer? Between 1, 2, 3, and 4.
4.
Good. Quadrant 4 would have been my only other choice if it had been negative because of that restriction and the shading that we've already done, okay? So if it's positive, I'm going to go quadrant 1, and I'm going to go ahead and assume always that my theta is near the origin, and then I'm going to lay this out. So basically, the sine is 5 over 13, so the opposite is 5, and the adjacent, or the r, is 13. And this is my triangle. So I know you're wanting to actually find the angle. I know you're wanting it. You're like, wait, but we have to find that angle. I need a calculator. We don't really need to find the angle, because in the end, what does it actually want? It wants the tangent of whatever that angle is. So the tangent of this spot is literally just the y over the x. Or, in SOHCAHTOA terms, the opposite over the adjacent. Either way you want to look at that. So if I could just find those sides, I'm done. I don't really need the numerical value of the angle, I just need the proportion, or the ratio. So how do I find the missing side? Pythagorean theorem. Or some of you know your triples, and what is going to be the missing side? 12. So if you already know it's a 5, 12, 13, that saves a Pythagorean theorem. But if you didn't, just do Pythagorean theorem. And now we roll into the tangent of theta is what's going to happen. The tangent of theta is 5 over 12. That's the answer that it's looking for. So I thought that was very interesting to pop up on that little paper. Okay, I'm going to give you guys one more of this type to practice, and then we're going to be done.